All right, so we're going to begin looking at our last exponent rule. And this involves when we have a base raised to a power and then raised again to another power. In other words, there's more than one exponent for the same base. So let's look at what happens when we have this situation. If you have x to the power of 3, that's the same thing as x times x times x. X multiplied 3 times. Okay? So we have x times x to the power of 2. Again, when you when you raise something to the power of 2, when you're squaring it, what you're doing is you're multiplying it by itself. So that means we're going to multiply x times x times x times x times x times x. So let me write this out. Times x times x times x. So again, I know this is a little bit tricky. It might not be as clear as some of the other examples. But remember, when we square something, what we're doing is multiplying it by itself. For example, 5 squared is simply 5 times 5. In your way there. 5 squared is just 5 times 5. It's 5 times itself. If we had a million squared, it would be a million times a million. So if we have x times x squared, then we're going to have x times x times x times x times x times x. You're just multiplying it by itself. So the question is, how many total x's do we have now? Well, if you count them up, there's 1, 2, 3, 4, 5, 6 x's. So you could rewrite this as x to the power of 6. So then, if we're trying to come up with our rule, if we look back at the beginning, we look at our original two exponents. They were 3 and 2. And so all we needed to have done was multiply the two exponents together. And that would have given us our final result of x to the power of 6. So the rule is the power to a power rule. When you raise a base to more than one exponent, multiply the exponents. Okay, so we've seen now 3 rules. When we multiply bases that are the same, we add their exponents. When we divide bases that are the same, we subtract their exponents. And when we raise a base to more than one exponent, we multiply the exponents. Let's do a couple of examples. So, if you have j to the power of 4, and then again raised to the power of 5, we said the rule is multiply the exponents. So 4 times 5 is 20. So just put down your base of j, and then multiply the exponents, and you have j to the power of 20. Our second example, or our third example rather, has more than one variable. And you see that the exponent outside the parentheses is a 2. So what we need to do is multiply all the exponents inside the parentheses by the 2. One important point, if you have a term like the negative 2 that does not have an exponent, we know that the actual exponent is an invisible 1. So we're going to write the 1 in there, and the same thing with the a. There's also an invisible 1 there. So what we're going to do is just write down our bases and multiply each of these exponents one at a time by the 2. So I'll put down my negative 2. The exponent is 1. 1 times 2 is 2. Next, my base is a. Multiply the 1 times 2. That gives me 2 again. The next base is b. The exponent is 2. 2 times 2 is 4. The last base is a c. The exponent is 4. 4 times 2 is 8. Okay? The last thing that I have to do is to simplify my coefficient. It's negative 2 squared. Really, I need to make sure I have this in parentheses, because it's negative 2 times itself, negative 2 squared. Negative 2 times negative 2 is positive 4. So our final simplified answer is 4a squared b to the 4th c to the 8th. All right, your turn. Again, I'm going to give you one more. I'm going to give you one more problem, and go ahead and try it on your own. Pause it and try it on your own. If you get stuck, you can always unpause it and play and watch how I do it. And then check your answer at the end after you've completed the problem. Your last problem is 3x to the power of 7, y to the power of 4, z, all raised to the power of 4. Go ahead and pause it, take a stab at it, and then unpause it if either you need help or to check your answer. Okay, so the first step, we're going to take all the exponents in here one at a time and multiply by the outside exponent of 4. So the first base of 3 does not have an exponent, so we write a 1 in there. So we'll have 3, multiply the exponents. 1 times 4 is 4. The next base is an x. Multiply the exponents. 7 times 4 is 28. Next, put down your y. 4 times 4 is 16. And then the last base, the z, it needs to have an invisible 1. And we'll multiply its exponents. 1 times 4 gives us 4. The last step is to simplify. The coefficient 3 to the power of 4 is 81. And then rewrite your other terms. And you have your final simplified answer.